We have learned that water and minerals enter the vascular cylinder of plants by apoplastic and symplastic routes. But once inside the xylem, the water and minerals have to move up the plant stem to reach all the leaves and the topmost parts of the plant. This movement occurs against the force of gravity. The water and minerals that reach the xylem are called the xylem sap. Xylem sap sometimes has to travel very high in the tallest of trees. So, how is this journey made possible? Is the xylem sap being pushed up from the bottom, or is it being pulled from the top? Actually, both occur: upward push by root pressure and upward pull by transpiration. The effect of root pressure in moving xylem sap up is almost nil during the day when transpiration is high. It is effective only during night time when the transpiration rate is too low. Note that even during night time, mineral ions are being pumped into the xylem. The presence of the Casparian strip, a water impermeable layer on the endodermis between the vascular bundle and the cortex, takes care that the mineral ions that move inside the vascular bundle do not go back into the cortex. So, mineral ions get accumulated in the xylem. This causes more water to flow in from the root cortex. The concentration of mineral ions and the inflow of more water build up pressure inside the xylem. This pressure is what we call root pressure. In the early morning on a humid day, if you transversely cut the basal portion of the stem of a small plant, you will be able to see drops of xylem sap ooze out of the cut stem. This is because of positive root pressure. It gives an upward push to the xylem sap, forcing it to move up. Sometimes, low transpiration rate and the resulting root pressure together result in more water being trapped inside the plant than is required. This excess water is exuded from the margins of the leaves through specialized structures called hydathodes. The process is called guttation. Guttation occurs under conditions of high humidity when a saturated atmosphere prevents transpiration. This is manifested in the form of water droplets formed at the tip of grass blades or along the leaf margins of small herbaceous dicotyledons in the early morning. However, once the sun is out, root pressure is hardly of any significance in pushing up the xylem sap. Root pressure cannot compete with transpiration occurring during daytime. Transpiration. The loss of water vapor through the stomata is an important factor responsible for the upward movement of xylem sap. Transpiration pull acts as a negative pressure on the xylem sap. This negative pressure has an effect like a liquid being sucked up through a straw. There are other physical factors such as cohesion and tension which aid transpiration in pulling water upward. Scientists have researched these factors and have come up with the cohesion tension transpiration pull model to explain the aspect of water transport through xylem. This hypothesis takes into account the properties of water molecules and the mechanism of transpiration. Let's look at the nitty-gritty of this hypothesis. Hydrogen bonds form between adjacent water molecules. These hydrogen bonds cause cohesion, that is, attraction between like molecules. This causes water molecules to stick together and prevents the water column from breaking. Cohesion between adjacent water molecules is a principal factor for the occurrence of surface tension. Water molecules also attach to the hydrophilic walls of the vessels and tracheids owing to adhesion. Adhesion is the attraction between unlike molecules. Here, the attraction is between the water molecules and the walls of the vessels and tracheates. Cohesion and adhesion thus explain how continuous water columns are maintained in a tall plant. The continuous evaporation of water from the exposed surfaces by transpiration results in water molecules replacing those that have been lost to the atmosphere. As a result of cohesion, this causes the other water molecules in the water column to be pulled towards the surface.
So, transpirational pull aided by cohesion, adhesion, and surface tension is the primary mechanism of upward movement of water in a plant.